All right, we're going to give a quick proof of the right angle congruence theorem. So the right angle congruence theorem is going to seem like it's a somewhat trivial proof, and it is to a certain extent, because it's proving something that is pretty obvious to us. However, it's just going to save us a lot of time moving forward. So what it says is that if two angles are right angles, then they are congruent. So we're using this specifically. I mean, we could do this for any pair of angles, right? We could do this for if two angles are straight angles and they're congruent, or if two angles are 45-degree angles, they're congruent. But we're using this because right angles just come up a whole bunch. So to write our proof, we of course need three things. We need our given, we need our proof, and we need our diagram. So my diagram is going to be pretty straightforward. It's just going to be two right angles. So I'm going to call this angle, we'll just call this angle A. Actually, let's put that on the inside. Or let's just call it angle 1. How about that? And then we'll have another one over here. This will be angle 2. And then, of course, these are both right angles. Okay, so what I need then is my given. So in this case, I'll have two givens. So to get my givens, what I need to look at is the hypothesis of my statement that I'm trying to prove here. So if two angles are right angles, so what I have are angle 1 is a right angle, angle 1 is right, and also angle 2 is right. So whenever I'm setting up a proof for a theorem, my given should always be my hypothesis, and then my proof statement should be whatever my conclusion is. So in this case, I'm trying to prove that angle 1 is congruent to angle 2. And so this is just how proofs work. I'm trying to show that whenever this is the case, whenever I have two angles that are right angles, then what has to logically follow is the conclusion that they are congruent to each other. And so I'm setting up my proof to be exactly that. I'm saying that, what am I starting with? My givens. I have two angles that are right, and what I'm trying to prove is that they're congruent. And so this could be for any case. You'll notice there's nothing special about my diagram. These aren't, adjacent angles. They're not on the same line. They're not vertical. They're not anything special. They're just two angles that are right angles. That's all I know about them. So I'll go ahead and start this proof. So I've got statement number 1 here, that angle 1 is right. That's a given. And then I have statement number 2, which is that angle 2 is right. Okay, so where can I go with this? Well, I'm going to actually kind of work my way backwards a little bit and think about how I'm going to get to my proof statement here. Whenever I have two angles that are congruent, how do I show that two things are congruent? Well, generally what comes before that is that those two angles, their measures have to be the same. And so the question is, how do I know that these two angles' measures are the same? Well, I know what their measures are. Their measures are both 90 degrees. How do I know their measures are both 90 degrees? Well, it's because these two angles are right. So I've kind of worked my way backwards to get to my givens from my proof. And so now I'm just going to work that in reverse order to try and say that these two angles are congruent to each other. So what I said was that I need to talk about their measures. So I have angle 1 is right and angle 2 is right. So what does that mean is that I know that their measures are both 90 degrees. So I can say that the measure of angle 1 is 90 degrees. How do I know that? Well, it's because angle 1 is a right angle. So it's my definition of being a right angle. So I'm going to use a definition here for my reason. Of course, it's going to be in biconditional form. So an angle is right if and only if its measure is 90 degrees, period. And where did that come from? How do I know that the measure of angle 1 is 90 degrees? Or rather, how do I know that's right? Well, that came from statement number 1. And then I'm going to do the exact same thing for angle 2. So the measure of angle 2 is 90 degrees. How do I know that? Well, again, it's the definition of what a right angle is. So statement number 4, reason number 4, an angle is right if and only if its measure is 90 degrees again. And where did I say that it's a right angle? Well, that came back from statement number 2. And so now that I know both these angles, their measures are both 90 degrees, that means that if they both are equal to the same measure, their measures must be equal to each other. So that's statement number 5, that the measure of angle 1 is equal to the measure of angle 2. Why is that? Well, they're equal to the same thing. They're both equal to 90 degrees. So that is my transitive property. If I have two angle measures, they're both equal to the same value. So in this case, they're both equal to 90 degrees. Well, that means they must be equal to each other. So what do I cite here? Well, I'm combining together statements 3 and 4. So last but not least then, I can close this out with statement number 6, that angle 1 is congruent to angle 2. How do I know that? Well, it's the definition of congruence. If two angles have the same measure, that means they have to be congruent to each other. So I'll use my definition congruent angles here. Two angles are congruent if and only if their measures are equal. Okay, so let's recap this pretty quick. Or what do I have to cite? Just the previous statement, number 5. So recap this pretty quick. Again, I just want to emphasize the fact that I'm using these definitions here, these biconditional statements that go in either direction. And so every time I use a biconditional statement, I should be able to look at a part of it comes from something before, and then part of it leads to what I'm saying right now. So for example, statement number 3 here, the measure of angle 1 is 90 degrees. Well, I'm saying that angle is a right angle. Where did I say an angle is a right angle? I said that up here. And if and only if its measure is 90 degrees, where am I saying that its measure is 90 degrees? Well, that's in the statement that I'm currently making. And so I can go to each of these statements that I just made here and show where it's pointing to something before to get what I currently have. And I can do that for every single statement that I have, including, my definition down here at the bottom. Two angles are congruent. Where am I saying that? Well, that's what I'm saying right now. And then if and only if their measures are equal, where did I say that? Well, that was from the previous statement. So this is just my proof of the right angle congruence theorem. Yeah, it's pretty obvious, but hey, here's what it does. Every time that I have two angles that are right angles, I will need to obviously state that in two different statements that they're right angles, but then I can jump straight to my conclusion that they're congruent to each other. And so these 3 statements here in between, I'm cutting them out. I no longer need to write them because I have this theorem that saves me time and just go ahead and tells me that if two angles are right angles, then they must be congruent to each other.